Hello and welcome everyone. Thank you for joining us today for the 6 Things Critical to Cloud Optimization Programs webinar. My name is Daniela and I'll be the moderator for today's session. I'm excited to introduce Andrew Hillier, CTO and co-founder here at Densify. Hey Andrew.
Hello everyone.
And he will lead the session today and take us through lessons learned from leading large-scale cloud users. Today's session will run for about 25 minutes and will be followed by a Q&A. And we do love answering questions, so please log them into the chat box at any point. Just to ensure we get through the content though, we will save them until the end. And if we don't happen to get to your question, we'll just make sure to contact you directly with a response afterwards. Lastly, the session will be recorded and you will receive an email with the recording likely early next week. And with that, I'm going to pass the mic over to Andrew to get us started.
Okay, thanks Daniela, and thanks everyone for joining. I think we're going to take probably just under a half hour today to go through this. It's, as Daniela said, 6 things that are critical for cloud optimization programs. I think we've learned a lot over the years. We develop software, but we work with our customers to make the software work in the field, and we found some very critical things to make sure that if you're going to optimize the resources, the cloud instances that you're running, there's things you got to get right or you're not going to get anywhere. So let me start by saying who we are. If you're not familiar, Densify is SaaS-based analytics, and we basically optimize supply and demand. We continuously watch the workloads running in the cloud. We continuously model the different offerings in the cloud and containers and make sure everything's matched up properly so the cost is right, the performance is right. Again, so you're kind of running that nice balance. We do it across all 3 major cloud providers as well as containers. I'm not going to talk much about containers today, but we have other webcasts that go into a lot of detail on that. And I'm probably going to pick mostly on Microsoft Azure today. It just happens to be the slides I have, but we do the same thing pretty much for Amazon and Google with some slight variations because, of course, those clouds are a bit different. One of the problems that we see out there, and this is some Forrester research, I think it's Forrester in conjunction with HashiCorp, and I'll just build this out, is that there's a lot of waste out there. There's a lot of things the wrong sizes, things that are the wrong types of things. So this characterizes an over provisioning. We see that a lot, but we also see people buying the wrong products in the cloud, the wrong types of instances, and that's kind of compounded by this orange part, the skills. There's a bit of even if you're aware of this problem, it's very difficult to fix for multiple reasons, and I'll get into some of those. The general impact is usually a lot of waste, but at the same time, a lot of risk. We see both performance, potential performance issues, or at the very least, not leveraging things that could improve your performance. I'll talk about that as well. There's a bit of a gap in that the people that get the bill aren't necessarily the ones deploying the workloads. So we find that there's this distribution of responsibility. FinOps is kind of making inroads into kind of bridging that gap, but it's hard because the people who are deploying resources may not even care about the cost. They might just care about the app working. And so, there's a bit of a gap there, and I'll talk about that as well. One of the most important things, which I'll spend a good bit of time on, is that if you produce a recommendation for someone to do something and it's not a good recommendation, then that is just horrible. That will create all kinds of problems, and it creates a lot of distrust. So if you tell someone, hey, you should move to this newer instance, but the new one doesn't have a disk and it blows up, you're kind of done. You've lost all confidence, at least for a certain amount of time. So this distrust, it drives a lot of things. It's perfectly rational, and it means that you really want to get the right answers if somebody's going to actually action something. And again, I'll cover all of these things in some detail. All of this is kind of compounded by the fact that the cloud offerings are very complicated in many ways, and I'm going to pick on Azure in this case. If you're running on a standard DS4 v2, which is a fairly old instance, and it's probably not the right instance for your workload, there are much newer ones. It might even be the wrong size, or the wrong type of instance, but to figure out what to do is very complicated. So if you look at Amazon's offerings, Azure's offerings in this case, that's an 8x28 instance. There's a DS4, but you're not going to want to go onto that because that's older. That's typically a move backwards, unless for some reason it's really cheap, but they typically aren't. A DS4 v3 would seem like the logical progression from a DS4 v2, that doesn't exist. So you're kind of at a dead end there. There's a D4SV3, which has the same letters in a different order, which seems like it might be useful, but that's only half the size, roughly, not even really half the size, because the other one was a weird size. But you're not going to go into that one, even though it's got the same number. The D8SV3 is the one that's kind of the equivalent of what you're on, kind of, but it's still very old. So what about the D8SV4? Because that's a lot newer and seems like the right one. No, that one lost a disk. No longer has a disk, so you kind of blow up. If you were using your disk and you went there, there's a D8DSV4, which is actually appropriate, and then a D8DSV5, which is the newest of that line. And this is just one instance. So if somebody has thousands or tens of thousands of instances, it's really hard to figure out. And this still might not be the right answer, because in this case, we've seen this at customers. One of our customers had this issue where these ones don't have the same number of disks and network adapters, and that actually was a problem. So the devil's in the detail here, and I'll talk about how we have rules to kind of check for all this stuff. But even still, if we check for all this, it might not be correct, because that might not be the right type of instance. Maybe you're better off on a burstable or memory optimized. So even within the same family, it's difficult, but you might be on the wrong family to begin with. And Azure, as of last year, had over 600 different types and options for the VMs. And I like to joke that there's probably the exact right one for your workload in there, and you're probably never going to find it without analytics, because it's just too complicated, and nobody has time to do this on a one-by-one basis. And like I said, if you do this wrong, then you create all kinds of problems. And so a lot of people just end up stuck on the V2 or a V3. We hear a lot about people scratching their head saying, why is everybody running on V3s in the cloud? Well, it's probably because it's kind of hazardous to try and do anything else if you don't know what you're doing to move forward on the newer stuff. So that gets us to kind of the topic of the webcast, 6 critical things. And again, from all of this, you can probably get to some of them, but I'll just go through them. So in our view, and I mentioned this, if you're not precise, if you don't generate the right answer, you won't get very far. So you need to kind of, I consider it like a term with many equations. You can understand the disks and the hypervisor version and all these different things. It should be tunable, because what's the right answer for one company might not be the right answer for another one. We see some companies that don't want to use burstable, for example. So that should be able to be expressed through policy. And it should be capable of being done automatically and not having humans review it endlessly. So we've heard of people using products where they say, I've got a database full of recommendations I can't take. I have to manually review each one, or they're just suggestions. They're just vague suggestions. So precision is very important. I'll circle back on that in a minute. Transparency is very important. So even if you have the world's best answer, people need to know that it's the world's best answer. So you have to show your work. And so we see this as being extremely important. We have some big customers recently where this is the entire game, where giving reports to the app owners of exactly why this recommendation is what it is critical. If you don't do that, it's a black box, and people won't trust the recommendation. So, but if you show all the workload curves and all the details, that gets you forward pretty far. To get to those good answers, you need to kind of understand I'll call it workload awareness or software awareness. What's running? What's its pattern? How often is it running? What does its utilization look like? Is it critical? Is it production? All of these things can impact how you treat a workload. Knowing what software specifically is running on it is even better, and I'll talk about that. But you need to understand the kind of the workload side of the equation, the demand side. What is this thing? What does it look like? What's it doing? As well as what is the provider selling for you to run it on? What's underneath these things? And I alluded to some of these things already. The cloud instance, does it have a disk or not? Does it have enhanced networking, or does it have all these different features? How fast is it? How new is the chip? Does the chip have certain features that I can leverage? So the supply and demand side, getting deep into both those sides, is very important to come up with the right answer. Taking a monthly average of a workload is not really going to get you a very good answer. So the patterns of activity, and as well as the characteristics of the hardware, are needed to kind of really match those things up. And again, I'll talk about these things. Once you've got the great answer and you've got the reports to say why it's the greatest answer, it's important that go through the right process. So especially for cloud, we often see that you'll need to get approval, and you'll need to have some kind of process to go out there before you start just changing things that are running in the cloud. So socializing, approving, and there's a lot of subtlety here we've learned over the years as well. Like if you send a recommendation to an app team, don't send them another one a day later. Like hold off. So throttle, only send them the top recommendations. So you don't want to flood people with recommendations. You don't want to hit them too often because they have other things on their their day job. So there's a whole area around ITSM compliance. I'm not going to talk a lot about this one today. We did a full webinar on this and our ITSM integration. So if you're interested, there's another webinar on that topic. And then ultimately, even if I socialize and get approval, it needs to happen, and ideally it happens through some automation mechanism. So tying it into the pipeline, the deployment pipeline, policy engines, things like that, again, helps you actually action things. And it needs to work in conjunction with ITSM compliance, because a lot of times you don't want it to happen until it's approved, but when it is approved, ideally it would just happen automatically. So these are the 6 things that we've distilled down as far as what we consider to be critical to get right if you want to actually succeed in changing and optimizing the resources that you're running on. So let me go through these showing more detail about the analytics themselves and in the context of how Densify works. So the way we approach this problem is we get all the raw utilization data from the provider, from the resource manager or CloudWatch, and then we basically process that in a way that allows us to understand and model the patterns of activity across CPU, memory, IO rates, all that type of stuff. And we model it, in this case, you're looking at a 24-hour view by quartile. So that's kind of the typical model of what this workload does throughout the day. And it's all normalized to benchmarks. So you can understand how much horsepower this thing's using. It's using quite a bit for a short period of time at 6 a.m. It's not actually doing much during the workday, and then it gets busy again around 9 p.m. at night. So this pattern is very important because not only does it dictate the sizing, but even potentially the type of instance you're on. Maybe a burstable instance is going to be a better instance type for this. And of course, doing that across all the different types of utilization metrics is very important. Again, things like IO, I'll talk about more in a second. They are also critical to making sure you're running on the right type of instance. So learning that and then applying it, what we do then is analyze that against the provider catalog. So this is just a small section of the Azure catalog, some of the Ds, the D type instances. And we do that using a very deep policy. And this is what I mentioned earlier. So maybe production is different than dev test. Maybe I want to run things hotter in dev tests. Things like the IO, again, can dictate what type of instance I go on as well. The disks, I mentioned those earlier, disks, network interfaces. Do I need premium storage? Am I using a specialized feature of the chips? What's my time window for analyzing? Again, a lot of discussion on this lately, and so our customers, you can kind of say, am I going for a longer term view, a shorter term view? Do I want to catch a quarter end? All of these things factor in, so we can take that workload and score it against the provider catalog. And we do it against the entire catalog. We're just showing a part of it here. This is very important because there's a whole lot of things that you can't run on because you won't fit. So those tend to be the reds that we're looking at right here. There's a whole bunch that you can run on. You might fit, but you're not compatible. Maybe you don't have a disk. Those are kind of the orange ones we see here. And then the green ones are the ones that you can run on. They meet all the criteria. And of course, one of them is going to be the most cost effective. So that's kind of the tiebreaker. In this case, we're saying of all these options, the D8 DSV5 is the best one for this workload, which is exactly that spreadsheet or the flow chart I showed previously. This is that example being handled through analytics. So again, and the key here is that being very precise, looking at all of the terms in the equation. We don't want to miss anything here. If we miss some detail that causes this app not to work, it's the app owners or the engineer's job to make sure the app works. So it's their job to not take an action that is wrong. And I know there's a discussion a lot in FinOps circles around getting engineers to take action. Well, the first step is to give them an action they can take. That's kind of step one. Now, what about this D8SV5, which also kind of made an appearance on that flowchart I showed? Well, the engine's also saying, no, you can't do that because that thing doesn't have a local disk. And this rule is actually pretty smart. It actually also knows that you're doing I/O on your local disk, and that's all tunable. So if you have a local disk and you're using it, we're not going to let you go to one that doesn't have a local disk. So it's a pretty sophisticated check, which is, again, a pretty important check. And that goes to the transparency. So the reason why we said what we said and the reasons why you can't do other things we find are very important. Otherwise, this is all very abstract. It's just a bunch of colors. But when you get down to the details, what the analytics engine said is often very important for gaining trust in what the recommendations are. Now, I also mentioned hardware and software awareness. So some of the research we're doing, I'll talk about at the end about our partnership with Intel, is to model things like processor accelerators. So let's just say, for argument's sake, we're running Nginx, which is extremely common out there. Lots of people run lots of Nginx. If I run Nginx with the right SSL driver on the right chip, there's a feature called Quick Assist that greatly accelerates the encryption and the compression, like greatly accelerates, not just a little bit, like a lot. So if there's an opportunity, odds are you're probably already running Nginx, most companies are, and you're probably already running it on an Intel based instance type. You can light this up and you get a huge benefit. So not only avoiding bad performance by undersizing things, but there's actually opportunities to leverage stuff you're already paying for to get even greater benefits. So this is something that we've been focused on quite a bit recently, and we can actually fire a rule in our rule engine to say, you're running that software. If you run it on an instance type with this feature, you'll get a benefit. So this is actually coming out in just about a month. It's a brand new feature for us. And again, this not only avoids the pitfalls, but actually enhances the experience, enhances the performance, and there's all kinds of affinities around, ML, AI, anything IO intensive, anything doing encryption. There's all kinds of accelerators that you could be using, and you're probably already even paying for them in the infrastructure. And they're just included in a lot of the infrastructure. So in that front, it gets to my point 3 and 4. So understanding not just the workload itself, which you're talking about quite a lot, but the actual software that's running, and understanding the hardware and which hardware has which capabilities to a deeper level does confer some advantage here. It's actually a pretty good advantage if you're able to do it. Now, just a little more on this feature. Part of what drives this feature is a new thing we created that it attempts to detect software automatically. And it's not to do a software inventory. It's not going to find every piece of software, but it targets certain software where there's known to be advantages if you run them in certain ways by triangulating on a whole lot of data. And I won't get into this right now. We'll probably end up doing another webcast on this upcoming. This is, again, coming out in about a month. But the idea being that if we know enough data from the provider APIs that we can look at all the different things, what's the boot image, what's the security group, what ports are open, and get a good idea of what software is running in these environments, because a lot of companies don't have good tagging. So if it's not tagged well, which is most companies aren't tagged well, we can still get good understanding of what's running, and that lets us do all kinds of things. I mentioned processor analysis, but also a lot of our customers, for example, if they have SAP modules, you shouldn't downsize the memory on those things. They won't support it if you go below a certain amount of memory. So we can automatically identify that it's an SAP module. We can then automatically apply a policy that will treat it correctly for what SAP, what their support policies are. So this is a pretty powerful feature, I think. And again, what I already mentioned was connecting the software with hardware accelerators. Here you can see a whole bunch of Nginx running in this environment. If I can just easily make that stuff accelerate, or put it on the latest gear, which will make it accelerate, and usually the latest gear is the same price as the older gear, then again, there's a big advantage. So this is something new. This and those rules are coming up shortly in our product. But the importance here is that understanding both the supply and the demand to a fairly deep level lets you do some very smart matching of workloads to cloud infrastructure, especially as new stuff comes out all the time and they're becoming more and more specialized. The latest instance types from the suppliers are very specialized as far as the features they enable. That's part of that complexity in that catalog, with or without disk that I mentioned. So the ability to match these things more precisely becomes more and more important in our view. Now, all of this comes through an analysis. This is just what the analysis looks like. This is actually drilled way down into the details of analysis, showing a bunch of cloud instances with various recommendations. And you can see here, even here, the top one is the downsize, but the next ones are actually make it smaller and a different family. Like the second row is from an A3 to a D2, or at the bottom it's a D2 to an F4. So a lot of times you're not only the wrong size, but people are running the wrong type of instance altogether based on the workload patterns. And here's an example of one that's actually too small. The utilization in the bottom left there is getting a bit high for our liking, so we're going to bump it up to a bigger one, taking into account all the different models of utilization, all the busiest days, predicted days, all the IO, all that kind of stuff. So very, very precise answer. This link, that you see the blue link in the fourth column, is actually a link to what we call an app owner. So if you scroll to the right, you'll see all the data, and our APIs provide all this data, but that link is actually what we call an app owner report. So if I want to take this action, we actually produce a report that tells you, well, based on this policy, here's all your models, here's what we're predicting you're going to look like, here's the savings. And again, there's more to it than this. So it's a very detailed report with basically the rationale for why we're giving that recommendation. And this is what I mentioned earlier. This is hugely important for transparency. This is often what goes to the app teams to make them comfortable with this recommendation. And they can say, well, nope, I'm not comfortable for this reason. And then you can tune the policy until they are comfortable with this. And so it makes for a very powerful kind of feedback loop back to the app owners that, hey, there's a better way to run your workload, and it's very safe, and it's going to save a lot, and we know you're getting bothered by people to save money. Take this action. So again, this was for us something we learned over time, that giving someone the best answer isn't enough. You have to explain the answer and then let them use that answer in their process flow. So to that end, on the process flow, so let's just say, we've got analytics that hits the cloud APIs, comes up with this wonderful recommendation. To actually make it happen, again, it involves all of these things I'm mentioning. So we have an ITSM module that will let you open a ticket in the various forms so that can be then communicated to the app teams. Okay, here's your recommendation, or here's your set of recommendations. And that app owner report is usually an attachment. So this says, here's the recommendation, here's the rationale. If you agree, you can approve it and you can do it. So we see a lot of changes. There's other flows that I'm not showing here. Like we also integrate with BI tools and portals to kind of socialize the recommendations. But one of the most common ones is to just basically integrate with ITSM and then have the teams, for the highest priority ones, have them go and fix them. And that could be a manual process, or there could be various automation mechanisms brought to bear there. Now, the other way to do this is to then say, well, when we see an approval, let's just automatically make it so through a line of code. And we have a Terraform module that lets you put a line of code in Terraform files. We call this optimization as code, so that optionally you can wait for approval. You can just do it, or you can wait for approval. For clouds, usually you need some kind of approval. And then when it gets approved, the line of code automatically picks up the right answer from the APIs and makes it happen in the infrastructure. So this is a really clean way to do it. It basically, because the app teams, the engineers, they're busy. They don't want to spend time editing files and changing things and stuff like that. If it can just be done automatically with their approval, this makes everyone's lives better. And I think a lot of people, you hear analysts and Google and everybody say, by 2025 or 2027, all of instance selection will be automated. We see that quote coming out of analysts and stuff like that. And we think whether that timeline is correct or not, this is what's needed to make that happen. To automatically automate the instance selection in the cloud requires these things I'm mentioning. You can't make it, it has to be the right answer. It can't blow the system up. People have to trust it. People have to be able to approve it, at least initially. Maybe they'll say, okay, you get a blanket approval towards the end. But all of these things are required to make this happen automatically. Now, so I'll just take this slide and circle back on the 6 things. So we kind of overlaid the 6 things on this diagram. Again, precision. This thing has to create the right answer. It has to be able to tell someone the answer and why that answer is what it is. We've learned that it's very important. Understanding the details of what's running, so you're making sure you're getting the right answer. Not only to not make mistakes, but again, there might be some very smart things you can do if you know what's running and you know what the provider's catalog has in it. You can do some very clever things and get a lot of advantage. There needs to be a process to control the actual changes occurring in the field and a way to automate those changes happening in the field. So that's the same 6 things just kind of overlaid on this diagram. And again, we work with a lot of really large companies that kind of learn, sometimes the hard way, all of these things. That this is kind of our view of what's absolutely required to successfully automate and optimize cloud instance selection and cloud resource optimization. So with that, I'll just do one more slide. This is just kind of patting ourselves in the back. We like this interesting report. We found that Giga is now produce a report on cloud resource optimization, not a CMP report where resource is a small part of it. It's actually just focused on this space, and they've identified us as a leader and an outperformer in this area. And if you're interested in that report, here's the QR code and the link to get to that report. And they identified our strengths, our ability to do basically what I'm saying. Deliver confidence and actionable results that you can automate. And so don't just take my word for it. Again, I think this is recognized as a legit way to optimize cloud resources. So we're proud of that. So I mentioned that. You're welcome to grab the report and read it. And the last thing I'll mention, and I'll pass back to Daniela, is that I mentioned Intel several times throughout. We do have a great partnership with Intel, and they actually offer Densify as Intel Cloud Optimizer, and they will sponsor the use of it for a full year if you qualify. So there's a bunch of details around that. I won't get into them now, but what I've been describing here is available from Intel. They will sponsor its use, and you can find out if you qualify at this link. Again, there's certain requirements to be able to use that program, but I think it's all outlined in the page that's linked to here. And it's 27 after. I think we have time for a couple of questions. I'll just move forward and hand it back to Daniela.
All right, thanks, Andrew. And just some resources that may be of interest to everyone, and feel free to scan the QR codes for access. We do have a poster available for download, and the poster covers the visualization of 12 risks associated with Kubernetes resource management. And as well, Densify has recently launched a podcast, which we are quite excited about. It is hosted by Andrew himself, and it focuses on interviews with IT and technical leaders. Each of the episodes dive into a conversation with leaders on their career, as well as insights into the latest cloud trends and best practices. We have so far a few episodes with Liberty Mutual, Intel, and our latest one with Comply Advantage. They're all currently live, so check that out. And next slide, Andrew.
Okay.
And if you are interested in learning more about Densify, feel free to follow us on social. I do see that we have a couple of questions.
And I'm happy to take those, Daniela. I think they're good questions. So the first question is, in the busiest day example, is there a scenario where auto scaling is ongoing and a thing here ramping up for nighttime, down for daytime, etc.? So I didn't talk about things like scale groups. We also analyze scale groups. So they are different beasts. There's a different, and I think there's probably a webinar with that. If not, we can follow up with that. But we have specialized analysis for things like scale groups, where we track the number of nodes running, all the node utilization, the scaling, the scaling up down activity. We actually run simulations of the aggregate workload against the nodes, trying different node types to recommend the optimal node type and the optimal number. So we'll recommend the min and the max and the node type. So for example, and if you're running containers, which we haven't talked about, they typically run on the scale groups, and we also factor in the requests and limits of the containers running. So for example, a lot of times you might be better off running on a memory optimized node in a Kubernetes environment. So we will make that recommendation, and we'll say, instead of running between 2 and 5 smalls, run between 1 and 3 larges, or again, bigger or smaller. So we do a full simulation to say, this is based on your elasticity, this is the optimal node type and the optimal scaling parameters. So that's absolutely the case, for scale groups. If you're running a highly variable workload just in an instance, a lot of times, unfortunately, you're stuck sizing it just to the high watermark, because it won't get any bigger on its own. And so the second question, I think, is related to that. We wouldn't want to size for holiday at 3x all the time. So obviously, if you're running scale groups and it scales up for the holidays and down, that would happen automatically, and you wouldn't have that issue. If you're running in a standalone instance type, then yes, it becomes a challenge, because you don't want to oversize it for 90 days for the one day that's month or quarter end. So we do have policy controls over how much history you use to size. Do you use just recent history? Do you use long history? We have some customers that just size for the long history. We have some that kind of use shorter term and say we're going to be more dynamic in our recommendations. That requires you changing things quite a bit to go make them bigger and smaller. So if you have a very active set of recommendations, you need to have a very good automation mechanism. But again, ideally, scale groups would be eventually used for all the stuff, because that's what they're designed for, is to automatically scale up and down based on the load. So those are the two questions. I kind of blended them together, but they're both from the same person, so hopefully that helps.
Okay, awesome. And we are just at the end of the webinar now. So thank you, Andrew. It wraps up today's session. Thanks, everyone, for joining us, and we'll hope to see you at the next webinar. Bye.
Thanks, everyone.